All right, today we're cracking open a genuine cosmic detective story. The main character? A mysterious visitor from a whole other star system. This is the story of an interstellar comet called 3I, Atlas. And its behavior has scientists, well, pretty much scratching their heads. So let's start the investigation. So just imagine for a second. You're looking up at the night sky, you see a comet with its bright head and that long, gorgeous tail. You know, we all know that tail is supposed to point away from the sun. But what if it didn't? What if you saw a comet with its tail pointing towards the sun? It would be defying one of the most basic rules we know.
And that brings us to our culprit, Comet 3I/Atlas. Now, this isn't just any old comet. This thing is interstellar. That means it has traveled an unimaginable distance, from some distant star, right into our cosmic backyard, carrying all the secrets of its alien home. And the problem is, it's just not behaving like it's supposed to.
Okay, so a super quick refresher on Comet Physics 101. A comet is basically a big, dirty snowball hurtling through space. When it gets close to our sun, the heat starts cooking it, turning its ice directly into gas and releasing all this dust. Then, the solar wind, this constant stream of particles and energy from the sun, blasts that material straight back, and voila, you get that iconic tail. It's really fundamental physics.
Except 3I Atlas is just breaking all the rules. It has what astronomers are calling an anti-tail, a really distinct spike of light that's pointing right back at the sun. This is the central clue in our whole mystery. It's a feature that, according to everything we know, just shouldn't be there.
Now, of course, any good detective is going to rule out the obvious first. Comets from our own solar system can sometimes look like they have an anti-tail, but it's just a trick of perspective, a little visual illusion that happens for a short time when Earth passes right through the comet's orbital plane. But here's the crucial part. That's not what's happening here. This is no illusion.
And that leads us to the most compelling piece of evidence. This sunward tail isn't some one-off glitch, a smudge on a camera lens. Nope. It is a persistent, well-documented clue that's telling us something really, really strange is going on.
Let's just look at the timeline. It was first seen really clearly by the Hubble Space Telescope way back in July. Hubble took another look months later, on November 30th, and yep, still there. Then on December 13th, a totally different telescope in Thailand confirmed it again. The key here is that this is happening over months, from different places and at different distances. This isn't a fluke, it's a pattern. And it gets even deeper than that. This bizarre feature isn't just in a few official photos. It's been captured in thousands of images, from the biggest, most powerful observatories on the planet, all the way down to amateur astronomers in their backyards. And when that many people all around the world are seeing the same impossible thing, you know you've got a real scientific mystery on your hands.
So if it's real and it's not an illusion, what on earth, or, off it, could possibly be causing this? Well, the scientific community has kind of narrowed it down to two main theories. You can think of them as the two primary suspects in our cosmic whodunit.
All right, let's line up our two main suspects. Theory number one is the sublimating ice model. So picture this. The sun is blasting the comet, and patches of ice on the side facing the sun don't just melt, they sublimate. They just flash boil directly into gas. This theory says that happens so violently that it creates a jet of gas that shoots forward, towards the sun, before the solar wind can even react and push it back. Now for our second suspect, the lagging debris model. This one's all about our point of view. It suggests the comet itself is accelerating, just a tiny bit, maybe from its own gas jets acting like little thrusters. As it speeds up, it leaves behind a trail of bigger, slower chunks of dust and rock. From where we are, here on Earth, this trail of cosmic breadcrumbs left behind the comet just happens to look like it's pointing at the sun.
And here, we have a huge clue that seems to favor theory 2. This quote from NASA's Jet Propulsion Laboratory is key. Their data confirms the comet is getting a little push, an acceleration that isn't from gravity. That is a massive piece of the puzzle, because that little push could be exactly what's needed to create that trail of lagging debris.
So, this brings our whole investigation to a really critical moment. The clues have been gathered, the suspects are lined up, and we are getting really close to a moment of truth. An astronomical event that's going to put both of these theories to the ultimate test.
On December 19th, Comet 3I/Atlas is going to make its closest flyby of Earth, coming within about 270 million kilometers.
I know, that sounds like a huge distance, but in cosmic terms, it's close enough for our best telescopes to get an absolutely amazing, clear view and hopefully crack this case wide open.
So, what are they going to be looking for? This is the beautiful part of science. We have very clear, testable predictions. If Theory 1, the sublimating ice idea, is right, then that glow pointing at the sun should be really unstable. It should flicker and change quickly as different ice patches erupt. But if Theory 2, the lagging debris model, is correct, then that anti-tail should be much more stable, a steady feature that only changes very slowly. The evidence is going to speak for itself.
So you might be thinking, okay, this is pretty cool, but why does one weird comet from another star matter so much? Well, because solving this one single riddle could unlock some profound secrets about all the other countless solar systems out there.
I mean, think about it. By studying this one visitor, we can pick up clues about the density of dust between the stars, or how water ice is scattered in planets forming around a different sun. We can learn if comets from other places are built differently, if they break apart in weird ways. Every single observation is like getting a sample from an alien world. It's a total treasure trove of information.
And this quote just gets right to the heart of it. These things are cosmic time capsules. They're not just rocks. They are messengers, and they carry a history written in dust and ice from a time and a place that we can never, ever visit ourselves.
And you know, that's really the best part of science, isn't it? Real progress doesn't come from finding things that just confirm what we already know. Science thrives on the weird stuff, the puzzles, the things that just refuse to fit in the box. When the universe throws us a curveball like this comet, it forces us to get smarter, to expand what we thought was possible. The detective story of Comet 3 I/Atlas is still being written. It's this brilliant reminder that the cosmos is just packed with more wonders and surprises than we can even begin to imagine. And it leaves us with this one last incredible question. As more of these interstellar travelers start passing through our neighborhood, what other impossible secrets are they hiding right there in plain sight?